Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, once again, dear students. Welcome to this 30-minute session. I hope you are there and you are paying attention. I'm glad that I will be with you in this lesson. And we're just looking at the calculations involving the titration reactions. How do we carry out these calculations that involved in the titration reactions? Please make sure you have your calculator ready with you. And of course, with the, where necessary, you may need the periodic table as well. And the notebook and the pen. Of course, those ones are very important, even if I don't mention them. Once I mention that we are in calculations, then you know a calculator is very important. Or if you trust your math, then you can do it with it. But I hope the calculator will do better. So we were doing the calculations involving the titration reactions, and by the end of the lesson, we'll be able to familiarize with these calculations and be able to carry out and perform the calculations as much as possible. So without wasting a lot of time, that is question number one. In a titration involving potassium hydroxide solution against a solution containing 1 molar per decimeter cubed of sulfuric acid, 28 cubic centimeters of acid was found to neutralize the alkali. So you need to first interpret the reaction or the question first. So you are having potassium hydroxide is reacting with the solution of potassium hydroxide is reacting with the sulfuric acid. This will give potassium sulfate and water. So this is the most important part of the reaction. Actually, they are even asking us to write a word and a chemical balanced equation. So if you write there, this is potassium hydroxide plus sulfuric acid. That gives us potassium sulfate. Potassium sulfate plus water. So that is the word, that is the chemical equation. Is it balanced? No, it is not balanced. So you need to balance it. Start with potassium there. Hydrogen is there, 2 here. So you need another 2 to make them 4. That is a balanced reaction. So they said, part B, name a suitable indicator for the titration and state the color change you would observe at the end point. The indicators that we have used, all of them are suitable. So the indicators that we have used, that was part A, B, we can use phenolphthalein indicator, or methyl orange. The acid-base titrations, strong acid, strong base, these titrations are the suitable indicators. State the color change. If you use phenolphthalein indicator, you remember titration involving against a solution of 1 molar. Solution against a solution containing 1 molar sulfuric acid. So potassium hydroxide, so say phenolphthalein here, if you use phenolphthalein indicator. In the acid, remember, we said it is colorless. And in the base, it is pink. So here you'll have the acid was in the conical flask, and the potassium hydroxide is coming from the bullet. So that means it is turning from colorless, moving from colorless to pink. When you add the indicator here, it will remain because it is colorless in the acid. So at the end point, it will turn to pink. So at the end point, the indicator turns pink because it is from acid to base. Calculate the concentration of the alkali in moles per liter. That is the molality. The concentration of the alkali. What is the alkali? Potassium hydroxide. So you need this. So you have potassium hydroxide plus sulfuric acid. So this is 2 and this is 1. So this is what you need. You have the molality of the base. Where is the molality of the base? 24. The molality of the base is what we are asked for. Volume of the base, that alkali, what is the volume of the potassium hydroxide? 24 centimeters cubed. What is the molality? What is the molality of the acid? Molality of the acid, what is it? So when you look at the molality of the acid, it is 1 mole per decimeter cubed. So this is 1 mole. This is 1 molar. What is the volume of the acid? At the end of the reaction, you see the reaction changed to the volume that was used was 28. 28, wait a minute. Involving 24, at the end point, the 28 of the acid was found to neutralize, yes. This is 28 cubic centimeters. So use this simple one. Molality of the acid times volume of the acid over molality of the base times volume of the base is equal. The acid is 1, so this will be 1/2. Take note of this. The acid, if acid is 1, that is why you have it here. If acid is as a denominator, then we'll make it 2/1. So it is 1:2. Substitute in the values. I think it becomes very easy. Molality of the acid, that is what we are looking for, times volume of the acid. What is the molality of the acid? 1 molar. 1 times the volume of the acid, 28. You divide by molality of the base, that is what we are looking for, times the volume of the base, 24. This is equal to 1/2. Cross multiplication. What do you get? So when you cross multiply, you will have 1 times 28 times 2, which will be equal to MB times 24. What do we do? Divide both sides by 24. Divide both sides by 24. This one will cancel out. So your molality of the base will be given by 28 times 2/24. That is times 1. So press the calculator. Can you press together? Because I told you you'll need the calculator to work out this. The calculator is needed. So you have 28 times 2, that is 50. 28 times 2, that is 56, divided by 24. That is 2.33. 2.33 moles per decimeter cubed. So that would be the molarity of the acid, of the alkali. Molarity of the base, that is what was asked. Can we move to the next question? 24 of solution containing 0.2 molar decimeters of hydrochloric acid neutralized 25 cubic centimeters of potassium hydroxide. 25 cubic centimeters of potassium hydroxide. So you have hydrochloric acid. Remember I said you need to write the equation first. It is reacting with potassium hydroxide. This will give potassium chloride plus water. That is a neutralization reaction. Is it balanced? That is the first thing that you should always note. Is the equation balanced? Yes, the equation is balanced. Look at the equation. It is balanced. So we are asked the concentration. Volume 24 of solution containing, so that is the volume of the acid. So the volume of the acid is 24.2 centimeters cubed. The molarity of the acid is given at 0.2 molar, 0.2 molar solution. What is the volume of the potassium hydroxide? 25 cubic centimeters. That is what is given. So the volume of the base, 25 cubic centimeters. The molarity of the base, that is what is asked. What is the concentration of this solution? So that is, the concentration is the same as molarity. So what else? Just simple as this. You say molarity of the acid, volume of the acid, over molarity of the base, volume of the base. This is 1 to 1. Where am I getting this one? 1 to 1. The reaction ratio here, this is 1, this is 1. The reaction, that is the importance of the reaction ratio. Once the reaction is not balanced, then you'll get a problem. So this will be molarity of the acid, 0.2 times the volume of the acid, 24.2 over molarity of the base, that is what is asked, times volume of the base, 25, 1 to 1. Cross multiply. What do you get? So this is 0.2 times 24.2 is equal to MB times 25 divided by, divided by 25, divided by 25. This one cancels with this. So your MB, that is the molarity of the base, not megabytes, please. Your MB is equal to 0.2 times 24.2 over 25. Press your calculator. Let us press together and see what we can get. So you have 0.2 times 24.2. You divide by 25. That is 0.19, 0.1936 moles per liter. Or you just note it as capital M. Number 3, we're just continuing and see whether we can. Let's do number 3. 24 solution containing 0.1 sulfuric acid. Now, sulfuric acid is reacting with sodium hydroxide. So you remember I said sulfuric acid, the first thing you need to do is to write the equation, sodium hydroxide. Then it gives sodium sulfate plus water. This is number 3. This was number 2, and that was number 1. So what is the concentration? It is the same. Remember the reaction ratio. You need to balance the equation so that you get the reaction ratio. What is the concentration of the sodium hydroxide? The method is the same. First, look at the question and see what you are given. 22.4 of solution containing 0.1 molar of sulfuric acid. So you are given the volume of the sulfuric acid, and you are given the molarity of the sulfuric acid. So you'll have the molarity of the acid, which is given as 0.1 molar. You are given the volume of the acid as 22.4 cubic centimeters. And then you are given the volume of the base, as 25 cubic centimeters. And then the molarity of the base, that is what you are supposed to look for. Remember the reaction ratio. The volume of the base, so you have molarity of the acid times the volume of the acid over molarity of the base times the volume of the base, which will be equaling. You see that? Sodium hydroxide, acid. So the acid is below. So that means sodium hydroxide, so we'll say 1/2. You see where the trick is? It is not always 2:1. It depends on what you have written, on how the reactants are organized. Did you start with the base or you start with the acid? So you need to note that one. The acid is 1, the base is 2. So that will be 1:2. Substituting the values, molarity of the acid, 0.1 times volume of the acid, 22.4, divided by molarity of the base, which you even don't know, times the volume of the base, which is 25. Equate it to 1/2. What is the next step? Cross multiply. This is simple mathematics. When you cross multiply, then you are getting 0.1 times 22.4 equaling to MB. I said the MB does not stand for megabytes. It stands for molarity of the base. Then times 25. You divide both sides by 25. Divide by 25. These 25s go. And then you remain with MB. That is the molarity of the base. What is that base? Sodium hydroxide. So you have 0.1 times 22.4 over 25. This is the same as 2.24 divided by 25. What do you get? Press your calculator. What will be the final answer? So when I press the calculator, I find that 2.24, I divide by 25, and I get 0.096. 0.096 moles per decimeter cubed. That is what you are supposed to get. So we can still continue and look at number 5. And if you look at the number 5, please 9, so this time we are given mass. You see now the trick, where the trick comes in. We are given the mass of potassium bromide, which was dissolved in 400 of water. Calculate its molarity. But I think we had done even some of the reactions similar to that. As we are trying to interpret the reactions, that question, let me just remove this part so that we can get the space where we can be able to calculate that. So you have 5.95 grams. So we need the number of moles. How do we get the number of moles? You remember from the senior 2 that number of moles is equal to the mass. The mass has to be in grams, remember that? Divided by the molar mass. The molar mass in grams per, the molar mass has to be in grams per mole. So this is the number of moles. So that means we need to calculate the molar mass of potassium bromide. We don't have the molar mass of potassium, so we need to calculate it. So the molar mass of potassium bromide is given by, when we are calculating the number of the molar mass, you remember we use atomic masses. That's why I told you that you need a periodic table. Now this is where the periodic table is applied. Use the atomic masses. Potassium is 39. You are adding bromine. Bromine is 80. So when you add them together, what do you get? So 3 and 9, so here you are getting 9, 3 and 8, that 1. Moles per, this is grams per mole, sorry. Grams per mole. That is the molar mass of potassium, molar mass of potassium bromide. So after getting the molar mass, we need to calculate the number of moles. We come back to the moles, which will be equal to the mass. The mass is given 5.95. 5.95 divided by 119. Calculator. What do you get? So you have 5.95 divided by 119. 5.95 divided by 119. 0.05. Is it what you have got? Moles. Now, remember, we have the number of moles. We have the volume, concentration. Remember, concentration in moles per liter or moles per decimeter is equal to the moles, is equal to the number of moles times the volume. Remember, the volume has to be in liters or decimeters cubed. So what do we need now? You have 0.05, that is the concentration. No, this is the number of moles, sorry. This is the number of moles, 0.05 times the volume. The volume is 400 over 1,000. Why do we divide by 1,000? To put it in liters. So that is, once if you cancel this and this, so we remain with 0.4. 0.4 times this, the calculator again. So I said your calculator is very important as far as these reactions. So you need to calculate 0.05 times 0.4, 0.02. So you have 0.02 moles per liter. That will be the molarity of this solution. Is it what we are getting? We need to move together so that you're not left behind. So, question number 5. What is the molarity of the solution formed by dissolving 80 grams? You see how it is related to this. 80 grams of sodium hydroxide. So you have 80 grams of sodium hydroxide. You have the volume of sodium hydroxide, which is 500 cubic centimeters. It is the same, so you get the moles of sodium hydroxide, which will be mass over molar mass. The molar mass is 40. Where am I getting 40? 23 plus 16 plus 1. I'm using the atomic masses. This is 2 moles. So after getting the number of moles, what do? We know that concentration in moles per liter is equal to the moles times volume. And the volume, remember we said it has to be in liters. So this is the same as 2 times the volume, which is 500 over 1,000. You remember that? So this is 0.5. So this is 0.5. So 2 times 0.5. What do you get? Isn't it 1? 2 times a half. 0.5 times 2. That is 1. This is 1 molar per decimeter cubed. So I will leave you with the, that is, they were asking, I will leave you, that is question number 5. What is the molarity? What mass of hydrogen chloride is needed? That was question number 6. I think it is, there is a wrong numbering there. It should be number 6. What mass, so I will review these questions. What mass of hydrogen chloride is needed to make this solution of concentration? So this time you have the concentration and you have the volume. So you need to calculate the number of moles. After getting the number of moles, then calculate the mass. So you are starting from here. You have the volume, so you need to calculate the number of moles. And you have concentration, which is 1. You have the volume, so you need to look for the moles. After getting moles, then use this formula to get the mass. Moles is equal to mass over molar mass. Hydrogen chloride, so you use the atomic masses. Then number 6, how many moles? So you have those 2 questions, and just look at the questions and then continue and work on them. Thank you so much for being with me. I hope you have been following. If you try those 2 questions, then you'll be able to, and you can be able to get the answers, then I hope you'll be following. Look for other questions to work on. Thank you so much. We hope to meet you in the next lesson. Bye-bye.